for the triangular matrix, not triangular matrix. Let's continue looking at its properties and some examples. So let's first copy it and paste. We know that a triangularizable matrix is similar. Okay, this word is important. Similar to a triangular matrix. So what does similar mean? How do the similar tell us? Well, we can have the similarity by the formula triangularizable matrix. We note as T. And the triangularizable matrix, we note it as A. And what is P here? P is the basis of generalized eigenvectors. Great. Now we have an example of the how can see transform a triangularizable matrix to a triangular matrix. These words are different. Notice the differences can make you learn better and know the know the tricks in tests. Let's see an example. Let A equals 1, 2, 1. Question A. What is the characteristic polynomial? Question B. What are eigenvectors and transformation matrix? Question C. Find T. So for question A, we have we find the quickest way to expand it. It's this. So we expand by 1 times 3 times 1 minus 0. So we got the first characteristic value is 1, the second is 3. So for these values, we now find their eigenvectors. First, we calculate x, y, z. So what does it mean? So what V forms the null space or kernel, whatever you like, of A minus lambda I. It is a solution. So now we find a solution and we find an vector v1 is for the eigenvalue 1, we have therefore we can calculate another eigenvector which is 1, 0, 0. Great. What do you notice? That the space is the degree of the space is 3, but we only find 2 independent eigenvectors, which means something is missing. Yeah, what is missing? Another vector which is called generalized eigenvector. And another vector is just E3. So we have our transformation matrix. And by some steps, we have its invertible matrix. And finally, we got an triangular matrix. Well, what is the purpose here? Or what can we notice is that the result is triangular. However, it is not that I can see clear to see that A is triangularizable. And now for linear algebra, we have many exciting properties, but here let's see, we make it clear that to get t, you need one, find of A. Number 2, what we have done is find a generalized vector. Number 3 is form the transformation matrix. Number 4 is calculate. So that's some basic ideas for the triangularizable matrix. Well, it comes from the triangular matrix, but we can find that something we are familiar here is just the diagonal. In this example, we have the diagonal also be the characteristic polynomial. And how to verify this? Well, pause the video and think that, and I think this will help you. Yes, the answer is one word: similarity. What the functions does P do is that it takes a matrix to another, and we have similar characteristic polynomials. So a better way to think of its triangularizable is when you notice it is of this form, yeah, and you say, oh, it must be similar to the triangular matrix. Well, the proof is left as exercise. And our next topic should be diagonal matrix. Thank you for your listening.